very much for coming along again to Eco Views and News. This evening we're going to look a little bit at the whole question of the ecosystem and how it functions with reference to climate, especially in soils. We're very fortunate this evening to have with us, for the evening, Jim Laurie, who's done a lot of work on the integrity of soils and their importance for maintaining total system balance. Many regard the response to the buildup of carbon in the atmosphere as something that really isn't new in some respects. That is, it's the question of balance. And if we release carbon by the way we're using things on this Earth's surface, there ought to be, in a balanced system, the way to reabsorb that carbon. And Jim is one who's looked into this in great detail and is going to share some of his thoughts with us this evening. So, Jim, it's all yours, basically.
Okay. Hi, Cambridge. I would like to start by talking a little bit about something that's been going on recently. There were a lot of demonstrations. There were maybe 5,000 demonstrations around the world last week in preparation for Copenhagen, and they kept talking about 350. And Bill McKibben, for instance, would say something like 350 is the most important number in the world. And that's the amount of, that's the ppm of carbon dioxide in the atmosphere. But we happen to be right now at 390. So we have to get it down. And Jim Hansen feels like, well, 350s would be an improvement, but maybe 325 or 300 would be even better. And he's the top atmospheric scientist. We are in danger, and we need to figure out a way to get the carbon out of the air and back someplace else. So, it's, how do we get to 350, or how do we get to 300? And why don't we make soil and end global warming? The day I was born 60 years ago, the number was somewhere around 310. And this is my kind of map of a way to do that. And this has been done before. This is how I, the climate that we had when I was born was much healthier, I think. And so if you look at this chart, if you look at the right side of it, you'll see you see a cow there hanging out with some sheep in West Texas. And the sign says, it says, megaherds of buffalo or well-timed pulsed grazing of livestock. And essentially, these animals eat grass, they make a lot of dung and manure, and they leave it on the ground. And they chew up the ground with their hooves, and then they move on. And in a healthy system, they move on, if they're managed in a good way, or if there's predators around. So, and you see down below, you see dung beetles. And they bury the stuff in a healthy system, and a lot of that stuff becomes humus. It's essentially the final product of bug poop. It's stable carbon in the ground. And you see some of the carbon farmers in Vermont over there. These are Abe Collins's kids up there, and the cows are ready to go. They're ready to move because they move their cows every day to new grass. And they're able to put a lot of carbon in the ground in that system. And so that's the first part we're going to talk about. We'll go to the next. What if we could put away 200 gigatons, 200 billion tons of carbon into grassland soils? That would be about 20 tons per acre on 10 billion acres. And that would take 20 to 40 years if we could capture a half a ton to a ton per acre per year. Is that a lot? It doesn't have to be. And where would these 10 billion acres be? And you say, well, they could be in North America. Much of Nevada used to be grassland. It could be in really dry climates. So anywhere east of Nevada would be excellent. You see how much of Africa is green on this chart. In South Africa now, parts that we call deserts, the Karoo used to have millions and millions of animals, millions and millions of springbok. You look in Australia, you see that the whole continent is green. And Australia is actually making a claim that they could capture huge amounts of carbon. And we'll talk about that a little bit later. And then, of course, Asia. There's huge deserts forming in China. and people are trying to plant trees and so forth, but the climates are very brittle, very dry, and trees don't have much of a chance if you don't have soil. So how do we make soil first? And let's go see. I have some friends out in West Texas, the Maddoxes, Joe and Peggy Maddox, and this is a neat picture because it shows a ranch that they took over management of in the West Ranch in 2002. And if you look at the upper right there, you see a lot of the ranch looked like this. It was prickly pear, cactus, and rocks, and not a lot of perennial grasses at all. But if you look at the, and that was 2002, and if you look at this picture in 2007, this area's got a lot of perennial grasses, a lot of green, and how did they do that? You know, and if you look at the right, do you see any prickly pear in that picture? And so let's see the next. And this is what they did. The state of Texas recommended a certain stocking rate, and they went to 2.5 times that rate. They actually used more animals, but they moved them in herds, and they moved them once a week. They had 25 paddocks, and they moved these animals once a week. And you'll notice that these animals, these sheep, are running a lot of grass. There's not, there's still bare ground there, but the perennial grasses are starting to show up. And the bare ground on West Ranch now is about 30%. It was about 70% when they first started. So now the other thing is that they used to spend, when in the previous ranch, they spent a lot of time trying to manage for invasive species. They thought mesquite, the trees you see in the background, and juniper were invasives, and they spent a lot of money on chemicals to get rid of these plants. And they decided they couldn't afford that, so they stopped. They don't use fire ever. And what it's done is it's changed their cash flow, and the animals like the shade, you know. So this is, you know, invasive species don't have to be a problem. As the moisture builds in the soils, the juniper will probably disappear because they're not very well adapted for moist soils. So. And this is something that they never saw in 2002, was that when it rained, the water would go into the ground and it would come up in these springs. And in 2002, the water would just run right off the land, and it takes some of the soil with it. The soil was almost like concrete. And the idea of having animals on the land in intense packs, herds, the hoof action really changes, and the water goes in and it becomes clear. And so this pond, they had pretty good rains in 2007, and this was, you know, several months that this pond was looked like this. And this is a picture of Malcolm Beck, who's the guru of composting in Texas, and he came out to visit the ranch, and he couldn't believe it because he was finding species of grasses that you can't find within 100 miles anymore out there in that part of Texas. And this is cane bluestem. They're seeing side oats, grama. You know, they're seeing Indian grass. They're seeing things that are really, really healthy for the animals, and pretty dense in places. And this is the goal for the whole ranch, that someday it'll look like this every year. So.
And these cases are written up on these websites here that you refer to?
Yeah, this idea, this holistic management process started with a guy named Alan Savory, who grew up in Zimbabwe. As a kid, he'd roam around the bush a lot. There were lots of grazing animals, lots of predators. He'd see sometimes dozens of lions in an afternoon. And as he grew up and became a game manager, and wildlife started becoming scarcer and scarcer as they were managing it, and he couldn't figure it out. But he had training in botany and zoology. And he thought, well, as Zimbabwe kind of went into civil war, he ended up in the United States, in New Mexico, because it got pretty dangerous for him to be in Zimbabwe. And he thought, well, now I'm in the United States, and the land, we'll have better land management there, and we won't see the land as devastated as it was becoming in South Africa. And what he found out that the land was actually dying faster. And so we were destocking the land so fast to put them in feedlots in the United States that the grass didn't have a chance. Grass needs nutrition from the animals, and it needs to be grazed, you know, once or twice a year in most places. The Maddox Ranch, it's twice a year. Every 6 months they come through, and they're seeing more grass every year. If they weren't seeing more grass every year, they would change their management structure, because that's part of their holistic goal.
So it's a question of how often and how densely the animals are in effect herded around the land mass, and redepositing their own manure is the self-manuring part of it, and their hoof action reactivates the soil in some sense. It aerates it and it churns the manure in such a way that then grasses can take hold again. So in effect, the management strategy is more dense but more movement at the same time. It is a denser total presence of the hoofed animals, but then a movement of that over time. So you're not overgrazing any one spot over time. What you're doing is moving that through the system. Well, it's a very fascinating idea here.
And here's some of my heroes. This is an area where there isn't much grass. There's some plant there that I don't recognize, but this was a picture of the dung beetles. And when Joe Maddox first saw dung beetles come back to this land, I mean, he was down off his horse and he was in tears, because this is when he knew the thing was getting to work. And they actually did a study on one ranch, some folks from University of Texas. I'll show that in the next slide. But they found that you could put a ton of manure per acre. You could bury it overnight.
Really?
And I'd ask them, I said, well, a ton of manure, that's like one, pretty precise number. And they says, well, we were only out there a summer. It might be a much bigger number, But that they could say with confidence that a ton of manure can be buried overnight if you have a healthy system. And think about how much carbon's going down if you're doing that. That's the idea.
So these are the architects of the recarbonization of the soil here. These little busybodies. It's perhaps no accident that the Egyptians, the ancient Egyptians, used to reify the role of the dung beetles.
Scarabs.
The scarabs show up in the art forms and all of the efforts to recognize the importance of local animals. Scarabs show up again and again.
Scarabs are sacred.
Yes, they are indeed. Okay.
This is an amazing picture. This was pictures that the Richardsons, Pat and Dick Richardson from University of Texas, they got a call from a rancher, Mr. Davis from Oklahoma, and he had gone out one year. He couldn't afford chemicals anymore, and he quit using them. And a couple of years later, he went out and he noticed that where are all the cow patties? They disappeared. And so he called these professors out and says, I got bugs all over my cow patties and they're disappearing. And they said, great. And then they went out and they studied dung beetles all summer, and you can see the tracks that they live, how deep they can get in the soil. They bury their babies inside these little balls, and then that's how they grow up. That's what their babies need to get going. And this time lapse on the right side is it'll show you what will happen in 13 hours. You just saw this whole thing being transformed. And Pat, that comment there, she says, I counted 206 dung beetles exiting in 6 minutes. I could hear the activity in the cow pad.
Really?
And I thought, well, you had a fun summer. That was they're verifying that we can put carbon back in the ground. So.
Sure. Well, it's interesting, the notion of we. In effect, it's our biological allies who can put the carbon back into the ground.
Absolutely.
If we learn how to become the allies of the dung beetles.
If we learn how to become a part of a team, yeah.
Right,
could humans actually support this process and help this symbiosis? It'd be great.
Yeah, I mean, we'd be hard-pressed ourselves individually to lift a ton of manure in a day. But if we get our allies going on this, perhaps we could empower them to do it.
Absolutely. Think about how much effort that is if you're using machinery to do this.
Yeah.
So
like 206 dung beetles exiting in 6 minutes. Okay, that's pretty good.
So
our efficient little allies here.
So now, that was the story we thought in the 1980s. We thought that making humus was the key, and it was about burying bug poop or all the activity in soil. But then something happened more recently. The USDA started looking at something they were trying to identify, and they called it Glomalin. And it's essentially it's glycoproteins. It's sugar proteins. It's long chains, it's quite stable, it's very sticky, and it holds clumps of soil together and makes air spaces. And so we thought, wow, so that you can now have a way that all the little animals, the nematodes and the earthworms and the insects in the soil can move around a lot easier, and the soil can breathe, you know. And fungi would like that because they need to breathe too. They don't do very well in waterlogged soils. And so when you have soils like this, they actually start rising up like a cake, because you know, all this stuff being put in all the sticky stuff making these aggregates, and worms pushing things around and so forth. But then something else happened. They started noticing that there was more glomalin in some of these soils, especially in drier areas like the Dakotas. There was more than there was humus. That this might be a faster pathway than even the dung beetles, and that's real exciting. And so if you look at that chart there, you look at the top, the perennial grasses, if they're healthy and they're being grazed in a timely way, they take a lot of CO2 out of the air. They throw away the oxygen back into the air so we can breathe that, and they need a water molecule to make sugar. You know, every carbon you add on a water molecule, you end up with C6H12O6 for sugar. And then we found out that over half of the sugar that they were making, they were giving to the mycelium, the fungi network in the soil, the intelligent system in the soil. And we say, why would they give up all this valuable stuff to the mycelium? Well, we knew mycelium could go a lot farther with less carbon to find phosphorus and water and other things that the plant needs. So that was maybe a pretty good exchange. But then a few years ago, USDA said a lot of the stuff that the mycelium gets, it gives away, it just exudes these glycoproteins, this glomalin, almost like mucus-like stuff. And we said, why would they do that? Why would they do that? Why would they do that? And are they trying to stop global warming? And then my friend said, no, they're storing water. Glomalin will hold 6, 8, 10 times its weight in water. For every ton of glomalin you put down, it's 10 tons of water that you hold in the soil. So that was a dream come true, because we knew fungi were intelligent networks, but this was amazing. So
well, this is fascinating. We're going to try to, for a moment here, we'll see if we can actually go out to some of the source material that you mentioned in this article, and see if we can call it up from the web. Now, we may not have the proper web connection here, so it may not work. But if it does, we can go out to the article that was behind it.
Yeah. Now this
in fact, showed up in Science Daily as glomalin is the key to locking up low carbon.
And you look at the date on there.
This is July 2nd, 2008.
Yeah.
And Science Daily should be said, is not itself a research paper. What it is it's a notification of major research. But they have, in effect, key links to the research. So you should be able to get out to the research paper behind this by going down to the bottom, for example, and seeing where it was cited from. Well, this is adapted from materials provided by the U.S. Department of Agriculture. So it's the Agricultural Research Service, the ARS, of the USDA that put out this information back in June of 2008. Let's see if we can call it. There's a larger picture of the.
And this is the threads are the mycelial threads, and then the glomalin is the ball. You see the ball shape,
right?
And you see there's a lot of them there. And for years they didn't know what to think about this. It was too hard to study, you know. So.
And it's now they're discovering that's what's in effect holding the water.
It's a big chunk of it. The dung beetles are doing their part, but this is a big part, and this is like an intentional part. It's almost an intelligent process.
I see.
So fungi can't live in the soil if it's not enough moisture, and they're trying to figure out how to get through the dry season, and that's their strategy.
So their strategy is to store it and use it from there. Okay.
Now this is another one that I think. Prairie dogs isn't in my model yet, but burrowing animals seem to be a big part of it. And there was a prairie dog town in Texas at one time that was 500 million animals. There were maybe 5 billion prairie dogs in the West, and there was a lot of grass at that time. And so we actually actively kill prairie dogs, and I wonder if that's the best policy. But I'm not going to talk about that very much, but that's something that I'll... I want to talk about this woman, though. This woman's Christine Jones in Australia, and in some ways I think she may have the most important idea for our future. And she is essentially saying that in Australia would be a wealthier country if they started taking the carbon out of the air and putting it in the soils. Intense grazing is a good way to do that. And so she's linking that carbon as a resource, the CO2 in the atmosphere, and saying, let's put it in Australian soils. And maybe if we did this all over Australia, we could take the excess carbon out. And I thought, why aren't we saying this in the United States? Why are we going to let Australia have all the soil and all the wealth? And essentially, she's also saying that the organic matter in the soil, the carbon content in the soil, can double in 3 to 5 years.
No kidding.
So that could be 10, 12, tons per acre per year, or not 10, 12 tons per acre over that time. So.
Well, let's try briefly to get out to the website that she's associated with, amazingcarbon.com. And in fact, there's a great deal of information behind it. Adapting farming to climate variability. This is a House of Representatives survey, green agricultural stewardship scheme. Well, there's a bit of...
Well, I'll just point a couple. Like the mycorrhizal fungi is huge, and those are really neat articles. But the one towards the bottom is it's saying recognize, relate, and innovate, and it's about a 30-page summary of how to manage a farm to maximize your carbon sequestration.
I see.
And it's just brilliantly written and quite optimistic, and we ought to get on with it.
Okay. Well, it's listed out there as a PDF file, so any of you can pick it up as off our website. We'll put the links up there to it. But you'll see there's a 29-page paper, which when the web gets connected here, you'll see come up basically.
Yeah.
There's the article, Recognize, Relate, Innovate by Christine Jones, and you can have your little page directory over here and go down to various pages within it. The executive summary, the table of contents will give you a sense of what's there, getting the basics right, and regenerative land management is the concept we're moving toward here.
And I just say, the way I know that this works is on the Maddox Ranch. The land could hold so much more water within a few years of when they got started. They used to have floods with 2 inches of rain. And now they're watching 5-inch rains go right into the ground. It's quite remarkable.
Very impressive.
Now the good news is here in Pennsylvania, on this side of the water, Rodale in the last few months has come out and said 2 things. One, they said chemical fertilizers do not work on the land, and we have to stop using them because they kill the fungi in the soil. They kill the life in the soil, and otherwise you have, like concrete, you don't have soil. Soil is a living thing. And the second thing is the ground must be covered year-round if we want to sequester carbon. If we cover the ground year-round with cover crops and so forth, we can put down a ton of carbon per acre per year.
Really?
But if you notice in the bottom right there, they've got a machine that actually simulates animal impact. And they are just starting to say, well, we want to study mob grazing as a way to actually put the manure on at the same time we're doing the animal impact.
Maybe reintroduce the animals again. What an innovative idea.
And you see Paul Hepperly, who's really an outrageous, he's the research director, he's holding up a carrot there. He's a good guy.
Okay.
And, so that's kind of my story. The story started, this is a picture of Alan Savory, and maybe the most important book written in the 20th century is Holistic Management, which when he first wrote it, it was very hard to understand, but his wife, Jody, listened to the stories long enough that she could write. She's a better writer than he was, and he was too deep into it. So Jody's, the second version of Holistic Management is quite a book, and recommended. So.
Well, thanks very much for coming along and introducing us to all of this, because we're going to put up on the website a lot of the reference material that people can follow things with, especially this planet-tech.com, where a lot of the information can be obtained readily. But it's been very helpful to look at this. It leads into other questions about biodiversity loss and the like, and perhaps in the future we'll be able to look at some of that as well. World grasslands are pretty widely distributed and have a lot of assets to them, but we ought to start using them maybe as a way to sequester carbon. And looking at the evidence you presented gives us a brand new way to do that. It seems to me this is very helpful.